Throughout history, time has been pictured as something that flows, like a river that carries all events from the past through the present and into the future. This idea seems natural because it matches how we experience life. But this picture has long troubled physicists and philosophers alike. What exactly is time? Why does it appear to move forward and not backward? And is it truly smooth and continuous, or could it be more granular, built from tiny steps we simply don't notice? In the Millar Cosmological Model, or MCM, I offer something different. I propose that time isn't something that flows. It's something that gets written tick by tick by the very events that shape our universe. Here's the key insight. Every time a quantum particle appears, it brings with it its own allowance of space. And when that particle disappears, it leaves that space behind. That leftover space doesn't get erased, it becomes part of the fabric of the universe. And that act of leaving space behind, that's the tick of time. This isn't just philosophy. It's rooted in how quantum field theory already describes vacuum fluctuations, where particles pop in and out of existence one. But in MCM, these fluctuations don't leave nothing behind. They leave space. This is a subtle but powerful shift. These appearance and disappearance events are what I call blips. Blips aren't just random. They are the building blocks of time itself. And the structures that create these blips are what I call Arnies, tension structures bridging realms. An Arnie is like a tiny tension bridge. It has two ends. One end, the Tessie, anchors to the matter in our universe. The other end, the stuck point, anchors into a hidden realm beyond the observable universe. Between them is tension, a quantum pull that stretches across the Higgs membrane. Now, in mainstream physics, the Higgs field is a field that gives particles mass. It was confirmed with the discovery of the Higgs boson in 2012 at CERN 2. But the MCM reimagines this field as a kind of membrane, a two-sided sheet with matter on one side and hidden antimatter on the other. This structure means every particle in our universe isn't floating free. It's anchored, held by this invisible tension, and that tension is what creates mass. This isn't just poetic language. It's mechanically similar to how stretching a rubber band creates resistance. The more you stretch it, the more tension you feel. So in MCM, mass is tension, not a mysterious property gained by interaction, but a physical pull across the Higgs membrane. The memory fabric, a cosmic ledger. Here's where it gets even more interesting. Every time an Arnie pops into existence, it brings new space with it. And when it vanishes, it leaves that space behind. The universe remembers every blip. It stores these events in what I call the memory fabric, a kind of cosmic ledger that keeps track of everything that's ever happened. This idea has surprising parallels to John Wheeler's it from bit concept, where the universe is seen as a record of informational events 3. It also mirrors ideas from causal set theory, which treats spacetime as a collection of discrete, ordered events, not a continuous field 4. So in MCM, time is the growing record of these space-creating events. It's not flowing, it's accumulating, tick by tick. Blips, the ticking clock of reality. Let's focus more on these blips. Every blip is like a tick of the universe's clock. Not a mechanical clock, but a quantum one. These blips happen when an Arnie forms or dissolves, creating and leaving space behind. If no blips happen, time stops. If blips happen faster, time speeds up. Mathematically, time in MCM is expressed as t equals n delta t, where minus n is the number of blips, del t is the smallest tick, possibly connected to Planck time, about 5.39 10^-4 seconds, the smallest meaningful unit of time in modern physics 5. Blip density and gravitational time dilation. Now here's the twist. In high-gravity environments like near black holes, blips don't slow down. They actually speed up. Locally, this makes time seem normal, because blips are happening rapidly. But to someone far away, it looks like time is stretching, almost standing still. This matches what Einstein's relativity tells us about time dilation 6. The MCM offers a deeper explanation. It doesn't just tell us what happens, it tells us why it happens. While relativity shows us that time slows near a black hole, the MCM explains the physical reason behind that slowdown. It's because the density of blips, those quantum events writing the ticks of time, increases in regions of extreme gravitational tension. It's not that time itself is stretching like a rubber sheet. It's that the universe is writing more ticks into that region's history. To the person standing near the black hole, everything seems normal. Their clock ticks, their heartbeat continues, because their blip clock is writing away as usual, just faster than someone observing them from afar. This explains why time appears to slow down from a distance, even though locally it feels completely normal. It's not time breaking, it's time building faster in that spot. And that brings us back to the heart of the MCM. Time isn't flowing, it's being written, blip by blip, tick by tick, in every corner of the universe. That's the deeper story the MCM tells. And it's a story that's still being written right now.